Good morning. Today we are going to see spontaneous emission and stimulated emission. In last class we have seen induced absorption in laser. Okay, it is the second lecture in this laser. Okay, let us first refresh what we have seen in last class. Okay, I have drawn the diagram. Here this is the energy level in the ground state. This is the excited state. Let us consider two levels only. Yesterday we have seen, okay, last class. Now an atom is there and it is in the ground state. And when you give a photon or light intensity of energy E equal to h nu, the atom in the ground state is excited, absorbs energy, and it is excited to the energy level 2. That is called absorption transition. Yesterday we have seen, and we have seen some derivation also. What is the rate of absorption we have seen. Now we are going to see what is spontaneous emission. Okay, in the ground state to excited state, the atom absorbs energy and it jumps to the excited state. I have given example also. Your daddy is giving 50,000 and you are in an excited state. Just like the atom is in excited state. Okay, this is the absorption transition. Now we are going to see this only. That means an atom is there. This is the energy level E1 and this is the energy level E2. Okay, and the number of atoms here is N1. Number of atoms here N1 and here N2. Now here the atom is in excited state. We have seen. Okay. Now in spontaneous emission, this excited atom cannot stay for a long time. The excited atom cannot stay for a long time. Okay. It jumps from E2 to E1. Energy level E2 to E1. It jumps. When it jumps, it emits radiation. It emits radiation. Which radiation? Equal to the difference in E2 and E1. Okay. We can write it. Last we have written A plus H nu equal to A asterisk, excited state. That means in the absorption transition we have written. It is in opposite, in reverse order. That means it is excited state. Therefore, A asterisk excited state, which gives A plus H nu. Okay. Now it is called a spontaneous emission. Here we are not giving any radiation. Okay. Once the atom is excited, it cannot stay for a long time. Maybe it is equal to 10 power minus 8 seconds. The duration. Okay. Within that duration, it will emit. Okay. Now it emits and it comes to the lower state. It is called spontaneous emission. Okay. Just like you are excited and after purchasing some mobile phone, then you will come to the normal state. Okay, that means the energy absorbed, that means the amount you received is spent. After that, you are in a normal state, ground state. Just like here, it is a spontaneous emission. Now we have to see the probability. What is the probability? P21, because second state to first state, the atom jumps, which is equal to A21. Here, in last class we have seen it depends on the photon density. Okay, here it is not involved. We are not giving external agency. We are not giving external source. We are not giving external photon. Therefore, it is in excited state. It automatically comes to the ground state. Therefore, it equals A21 only. This is Einstein constant of spontaneous emission. Okay. Now this is the probability. Now rate of transition for spontaneous emission. Okay, we have to write. Then what is the rate of transition? It is the letter R and spontaneous emission. Therefore you write spontaneous SP. Okay, it is given in all the books. Therefore you write spontaneous SP only. Okay, which is equal to this probability. Okay, A21 and it depends on the number of atoms N2. depends on the number of atoms N2. This is the rate of transition for spontaneous emission. You have to understand this. It depends on the only number of atoms, and A12 is the depending on the energy state only. Okay, it is not depending on the photon density. It depends on the energy state only. Okay, this is the spontaneous emission. Now let us see the next one, stimulated emission. Okay, stimulated emission. Stimulated emission means what? Here the achievers, I have to say one thing. Achievers think differently. Okay, Einstein is an achiever. Therefore, he thought differently. How he thought? In the induced state, that means in the ground state, atom is there. We are giving one photon, and the atom is induced and it moved to higher state. Okay, that means ground state to excited state. The atom absorbed, or we made the atom to move to the higher state. Okay, that means absorption transition. And spontaneous transition, spontaneous emission automatically takes place. Now Einstein thought, if a photon induces an atom from ground state to excited state, why don't we apply the same principle for this transfer from higher state to lower state? Okay, that is Einstein thought. That means instead of moving from automatically from higher state to lower state, we are making the atom to move from higher state to lower state. Here the atom cannot wait, cannot stay for a long time for transition. That means before transition we have to apply energy, we have to give some photon, and we have to make this transition. Okay, that is called stimulated emission. Okay, understand? In spontaneous, we are not giving anything. Automatically, the atom comes to the ground state. In stimulated, before coming to the ground state, you are giving some energy, photon, and you are making the atom to move from higher energy to lower energy. Okay, now I will draw. Now this is the excited state. Excited state, the atom is in a excited, asterisk you put it. Okay. Now excited means what? Excited means it has one alpha particle, one HU photon. Now you are giving one photon. Let us assume one only. Okay. Now it has already one, and you are giving also one. Now this atom jumps. This atom jumps from E1, this is E2, jumps from E2 to the ground state. Now the atom comes here. While coming, it radiates or it emits 2 H nu. Okay, that means 2 photon it emits. The energy level is E2 minus E1. Okay. Earlier in spontaneous emission, only one energy H nu was emitted. Now here you are giving one H nu, and in addition it is having its own H nu. Therefore 2 H nu are coming. Okay. Now we can write this atom plus H nu, which is equal to A plus 2 H nu. Now these two are in phase and these two are coherent. That means now the light is amplified. This is the principle of laser action. Okay, that means this atom in excited state to ground state jumps. While jumping, 2 H nus are emitted. That means both are in a coherent form, in phase, in frequency. That means light is amplified. Okay, now let us write the equation for this. Here the same thing we have to write. It comes from second state to first state. Therefore P21, which is equal to, okay, B21 rho, okay, just like absorption. Okay, it depends upon the photon density because we are giving photon, and we can write R it is spontaneous, now stimulated, therefore you put ST, okay, which is equal to B21 rho and N2, okay, because N2 it depends upon the number of atoms in the second level, okay. This is the relation for, and B21 is the Einstein coefficient, and this is the photon density, and this is the number of atoms in the second level, okay. Now this is one important relation, this is also important relation. Now what are all the characteristics, okay, for this spontaneous emission and stimulated emission? For spontaneous emission it is random, okay, because automatically it is happening, and it is it is not monochromatic, okay. Monochromatic means only single wavelength should be there, and incoherent, and intensity equal to N into I only, number of atoms into one photon intensity. I is the photon intensity only, that is intensity of a single photon. And here in stimulated emission means it is controllable. That means we are making the atom to jump from higher state to lower state. Before it jumps, that is you have to understand, before it jumps we have to give a photon, and it jumps from higher state to lower state, and both are same frequency, same phase, and plane polarized, okay. And intensity is number of atoms into, that is square of number of the atoms, and I, intensity of a single photon. That means intensity is increased, that means intensity is amplified, okay. Intensity is amplified. I will write in a different diagram. Now single atom is there, I will put it there. Single atom is there, you are giving, and it is in an excited state, okay, and you are giving a one photon H nu, and now this emits two H nu and H nu. This is the original H nu, and this is the we have sent, induced. Now these two will strike again another one, this one and this one. Now it will give two, just like the process is chain reaction, okay. Immediately all are happening, therefore the light is said to be amplified, okay. This is the concept of stimulated emission, okay. And next class let us see the Einstein relation between these three Einstein coefficients, that is very important derivation. Thank you. Please subscribe and put a comment.